Let's create assembly design now. So already we have created parts and we have saved it one separate folder. So now we'll go for assembly design. So already saved parts to insert into assembly, we can use here these two options. One is existing component and one more is existing component with positioning. Existing component means, so just I'll click on product. I need to open this fork. Let's say open. Now, for example, one more part I want. So just again, if I go for existing component and on product, if I try to open this part also it will come with reference to same axis system. It means we are not able to move this part while inserting the part. So in that case, we can use here existing component with positioning. And if I select this any part and if I try to open this, we are able to move and we are able to make proper position for that particular part. So that is the difference between existing component and existing component with positioning. Now let me close this and let's enter into new assembly design. So first part we can use here existing component and we need to click on product. So first I need to call this fork. Let's say open. Now whenever we are going to create an assembly design, one part will be fixed. So that part we can fix by using this fix component. Just click on this part. As you can see here, this part is fixed. Then next to that, I will go here with existing component with positioning under this product. I need to call this center block. Let's say open. Just I'll drag and keep it somewhere here like this. Then we need relation between this axis to axis exactly at center. So we can go here with coincidence constraint between axis to this axis. Let's make it here update. Then next to that, we need to apply relation between face to this face, or else exactly at center we can make it here plane to plane. Now just I will go here with again coincidence between plane to plane. Okay, let's make it update. It will fix exactly at center. Then for this part, we need to check degrees of freedom. So just we can mouse right click on that. Under delete, part name will be showing. Just you can go here with component degrees of freedom. We are having here rotation with reference to this Z axis. It means in which direction we need to apply some motion, that relation we should not apply. Now for this assembly, we are going to arrest all degrees of freedom for every part. Now to arrest that rotation, we can use here angle constraint. We are having rotation with reference to Z axis. So we are going to select either ZY plane or this ZX plane. Now we need to select this ZY plane. For this plane, we are having this plane parallel to that. So let me select these two planes. We'll make it here parallelism. Let's say okay. Now again, if I check degrees of freedom for this, as you can see, there is no degree of freedom for the center block. Then again, I'll go here with existing component with positioning. Now I need to open this pin. Let's say open. Just I'll drag and keep it somewhere here. Then coincidence constraint between axis to axis. Let's make it update. Again, coincidence constraint between this face to this face. This entire pin should be get reversed. So we can make it here opposite direction. Let's say okay and make it update. Properly it will get reversed. Then to lock rotation for this pin, we can go here again with angle constraint. Just we are having rotation with reference to Z axis. You can go with this plane or this plane. Now just I'll select this plane to this face. We'll make it here parallelism. So we need relation between plane to this flat face. We'll make it here parallelism like this. Then next to that, for this hole, we need to insert here split pin. Just I'll call that split pin. Then just I'll drag and keep it somewhere here like this. Same here also, relation between this axis to this axis. we need here coincidence. Let's make it update. Then this pin should be inserted inside exactly. So here we don't have any center plane. So in this condition, if you want to apply some distance between any two faces or planes, we can use here offset constraint. I am going to apply dimension between this plane to this face. Let's make some dimension between these to this. Just I'll give some 60 and I'll make it here update. As you can see here, still this pin should be inserted inside. I'll make it here some 45. Let me check with this distance. Yes, enough for this. Then for this pin also we'll be having rotation. So to lock that rotation, we'll go for angle constraint. Here rotation will be with reference to y-axis. Now just I'll select this plane. With reference to that, we are having parallel phase here. Let me make it here parallelism. Now again, if I check for split pin, here we have arrested all degrees of freedom for this. Then next to that, we'll go for this shaft end existing component with positioning. Under this product, we need this shaft end. Just I'll drag and keep it somewhere here like this. Then coincidence constraint between axis to axis, we'll make it update. Then coincidence constraint, this face, it should get attached with this face. Just I'll select this face. On the same direction, we'll make it here update like this. Again here also rotation will be there. So just we'll make it here angle constraint with reference to this plane to this plane. We need here parallelism. Let's say okay. So any plane you can select or any face also we can select. Then next to that, we need to insert here taper pin. Let me call taper pin now. Just I'll drag and I'll keep it somewhere here. Then, as you can see here, length we are having this and height we are having this. Now, if you want to rotate this pin here itself, we can go here with manipulation. You can use this option called drag around any axis. So we need to fix this axis and you are able to rotate this part like this. If you want, we can rotate and we can make it relations, or else directly if you apply relation, according to the relation applied, that part itself it will get rotated. Now we need again relation here between this face, it should get attached with this face on the same direction. Let's apply this coincidence constraint and I'll make it here update. So properly it has come at that end. Then next to that, we are having here relation, this pin exactly we need to insert here. So this we have created with multi-section solid. As you can see here, we are not having flat face, we are having here inclined face. So in these conditions directly you can't use face to face. We will go here with coincidence between this plane to plane. I will use here center plane to center plane. Just will make it update. Let me check that constraint. Just I will delete that. So we need coincidence constraint for this taper pin front face. Again, we need to make exactly at this front plane. Okay, update that properly. It will come at center. Then again, if we check degrees of freedom for this taper pin, just if I click here, we are having translation in up and down direction. Now, let me drag this by using with reference to Z axis like this. Now, this face, it should attach with this downside face. So again here also we are having this taper face. We are not able to apply directly this coincidence constraint or contact constraint. So in this condition we'll go here with offset constraint. We can give dimension between this plane to this. We are having here with a distance of 5 mm. Let's give the dimension and make it update here. So properly that pin will be settled at that position. Now same whatever we have done this side, same we need to repeat opposite side. Now again let me call this fork, existing component. We need fork. Just drag and keep it aside. Then coincidence we need between this axis to this axis. Then this face, it should get attached with this face in opposite direction. Let me keep it here opposite. Just I'll make it here update. So after applying relations also we can make it update. Now let me rotate this by fixing this central axis. I need this part in this direction like this. Let's say okay. Rotation will be there in this way. So just we'll make it here angle constraint between any face to face. It means this it is able to move or it is able to rotate in this direction. Just I'll make it this face to this face. We need here parallelism update. So properly that part will be fixed. Again I'll insert pin. Just I'll move and I'll keep it somewhere here. Then coincidence constraint between this axis to axis. Let's make it here update. Again coincidence between this face. It should attach with this face. It is in opposite direction. Update. Then rotation will be there. So to log that rotation, just I'll select this plane to this face. We'll make it here parallel. Then next to that, again I'll call this split pin. Before what we have applied, same relations we need to apply here also. So just we'll make it here coincidence between this y axis to this central axis. Then update here. Next to that, we need here some dimension between any face we can select. So this face to this plane, I'll make it some distance here with reference to flat face we need to take. So this plane to this face I'll take with a distance of, just I'll make it some 20. We will check with dimension. Still we need. So I'll make it here some 10. Let me update this. Enough. Then to log rotation, again angle constraint. This plane to any flat face. We'll make it here parallelism. Then again next to that, this shaft end I need to insert. Just we'll call this shaft end. I will drag and keep it somewhere here. Coincidence constraint between this central axis to axis. Let me update this. Then this face, it should attach with this inside face. We need here same direction update. Then to lock rotation, just we can go here with angle constraint between any this plane to any flat face. We can make it here constraint. So just we can make this to this any plane. I'll select and I'll apply here parallelism like this. Then taper pin again we need to insert. I'll call this taper pin. Just I will drag and I'll keep it somewhere here. Just I'll make fit. I will drag and keep it somewhere here. Now just I will rotate by fixing this central axis. I'll rotate like this. Then coincidence between exactly this center plane, it should coincide with this center plane. Let me update that. Then next to that, we need here relation between this top plane to this face. We can give here dimension of 5 mm. So offset relation between plane to this face, we are having distance of 5. Let me update here. So we need in reverse direction, just we'll make it here -5. Update. Then next to that, we need again relation between this to this. So just I will drag this with reference to x. We need relation between this face to this face. We'll make it here same side coincidence like this. Then at end we have forgotten to insert that collar. So just we'll go here existing component with positioning. We'll call this color. We need color somewhere here downside one. Now coincidence. This central axis to this axis will make it here coincidence. Update that. Let me drag that out. So just I will drag this out like this with reference to Z axis. Now again coincidence, this split pin axis, it should be inserted exactly into these holes. We'll make it here again update properly. Now it will be fixed. So to adjust this dimension, just I'll give somewhat more here. I'll make it some 50, make it update. So properly this pin will be inserted. Same like that, here also we need to insert color, existing component with positioning. We need to insert color. Just I will drag and I will keep it somewhere here. Then coincidence constraint between this axis to axis will make it update. Just I will drag this out with reference to this x-axis. Again coincidence we need with reference to this whole central axis to this split pin axis will make it update. Now again just we'll adjust this dimension. As we can see here, dimension from this to this we have given here 10. I'll make it here -5 and update. So properly it will be fixed. So in this way you can create this universal coupling. For example, if you want to hide all these axis systems and constraints at a time, as you can see here in specification tree on constraints, mouse right click, we can hide this directly. Then to hide all axis systems at a time, you can use Ctrl plus F. Then one pop-up it will come. Workbench you need to select as part design. Then type you need to select as axis system. Go here for search and select option. If I click here, automatically it will get search and it will be selected. Then we can make it here hide or show like this. Just I'll make it here isometric view. So in this way you can hide all these axis systems and constraints at a time. Thanks for watching. Keep supporting. If any doubts related to this you have, you can just comment it down in comment box.